Hello, everybody. Yeah, I'm Max, and welcome to my talk. Welcome to my talk, One Click to Root, Elevating Privileges Within macOS Jamf Environments. Cool. Who am I? That's the most important thing when you're starting a talk. I'm a security consultant for Reversec. I've been here nearly 3 and a bit years now. I primarily do like network security, infrastructure security, operating system stuff. I've got some certifications, not that they really mean anything, but I've got them. I've spoken at some conferences, basically all around the world. Most recently, I was in the US speaking at the SpectropS conference about some Active Directory Federation Services research. I've got some CVEs and some third-party macOS things, some application stuff as well, but primarily macOS. Cool. So let me introduce you to this talk. I'm going to go over the Mac in the enterprise, what the Mac, like the responsibility in the enterprise, like what's its purpose, why is it there, etc. I'm going to be talking about root, what is root, and what is privilege escalation, just in case there's anybody here that isn't familiar. I'm going to be covering some of our research, some of our findings, and some real-world exploits for client environments, for clients that are in this room right now. I'm going to cover why third-party review is a must and why it's important, and most importantly, a Q&A at the end. Cool. So that leads us on to the Mac in the enterprise section. Macs are everywhere. We see them, more and more every year. So macOS, we're getting more of it, and it seems like macOS is here to stay. Developers like it, people in productivity like it, and in my opinion, it's one of the best operating systems out there. More Mac in enterprise means we, as attackers, need to be familiar on how to attack these systems, how to leverage them in order to achieve attacker objectives, and security and privacy on macOS is not like security and privacy on Linux or Windows. It's very different. While there are some areas that overlap, it's not the same. You can't just take Windows privacy model, Windows security model, and apply it to a macOS device. As I just mentioned, while the OS itself is different, Apple have actually designed it to take privacy as its own type of control in mind, and we see mistakes that are consistent across client environments, and it's not necessarily their fault, it's third-party applications that introduce these vulnerabilities into environments. And at the end, I like helping to secure macOS applications and the operating system, and I'd like to do more macOS work if I can. Cool. So that leads us to what is root and what is privilege escalation. I'm sure there's like a mixed bag in this room, some people technical, some people not, so I'm still going to cover it. So cool. So with privilege escalation and root, imagine your computer has different levels. Standard user doesn't have extended access, and you might need to elevate to do things like change system settings or access sensitive areas of the system. Essentially, we typically see principle of least privilege implemented, which is good. Standard users don't have administrative access unless they necessarily need it. Typically, when we get access to an endpoint, it's through phishing, like you don't really get edge-facing macOS applications because it's all cloud and software as a service, but administration tools are a common avenue to getting onto a Mac, so if you're familiar with like most threat actors, they love calling up a user, hey, can you connect through this remote access software? Let me get access to your system, and they get desktop access, which is different to traditional command and control software. Getting privilege escalation or getting access to a root account allows you to extend your access, so improved persistence, ability to like basically stay undetected. It's much, much easier. And there are multiple types of privilege escalation. It's a bit of a misnomer, but there is vertical and horizontal privilege escalation. While horizontal isn't necessarily like an escalation up the ladder, it's still a type of escalation. Cool, so that leads us on to our real-world exploit section. So this covers, let me just get some water quickly. It's a bloody hot day today. This covers some real-world exploits that I personally and Reversec have exploited in the wild. Bit of awkward side of the bar. Fill up my water. Cool. So, if you're familiar with managing macOS, can I get a show of hands who has macOS in their environment? Cool. Does anybody use Jamf? Cool. Does anybody use anything else like Kanji or simple MDM? Cool, okay. So it's good. There's only one person with Kanji or other systems, so focusing on Jamf. So software can get onto endpoints in a number of ways. It can either be like initiated, so aka a sysadmin wants to set up a script to kick off an installation action to install a VPN, etc. Or it might be self-service, where a user might need to access a productivity tool or productivity piece of software, things like Figma and like all of those like R, etc., Python, like yeah. So Jamf self-service is a self-service application. It's in the title. It essentially allows users to request applications that have been made available to users. This can be authenticated, aka you've logged in through like an SSO provider, or it can be unauthenticated, things like troubleshooting scripts, etc. And essentially Jamf provides this as a piece of software available. Most importantly, Jamf self-service abstracts that need to elevate as the user. So Jamf by itself, the actual Jamf process runs as root. Self-service uses an XPC service to talk to it, and then it does the administrative actions. So the user doesn't need to have an administrative account. Jamf does all the magic in the background. And that's the most important thing about it. So cool. This leads us on to a first CVE that I identified on a client project. Essentially, it was an elevation of privilege vulnerability in an installer process. So there's a bit of a story behind this vulnerability. I was onboarding to client A's environment, and they were making use of VMware Horizon for their like VDI software. So I, as a macOS user, I got VMware Horizon client set up, and curiosity kills the cat, but satisfaction brought it back. I started looking at the actual package installer, what it was doing, how it was interacting with the file system, etc. I identified a case where it was insecurely using the file system for privileged operations, aka the installer was like writing things somewhere, executing in a place where a low privileged user could interact with it. I put together an exploit. I started drafting the vulnerability disclosure report to Omnissa, VMware, or whatever you want to call them now, the number of name changes, Broadcom, yeah. And around that time, I started another project for client B. And I noticed that client B was actually using the same software within their environment. It was available in Jamf self-service, and I knew there was a vulnerability in it. So essentially, I engaged the client. I was like, hey, I have this vulnerability that's in the disclosure process. Is it okay if I validate it in your environment and prove its impact? And potentially, you can fix this until VMware actually resolve the vulnerability in the installer. I demonstrated a vulnerability and got a CVE for it, 7.8 CVSS v3, solely because in environments where you have Jamf self-service, you can just trivially elevate to root. So cool. I don't know how ready people are to read code screenshots, but I've made sure to highlight the most important areas. As you can see here, the initiating process for the installer is running as root. If you look at the second box, there's a path where it's being used as like an intermediary directory. So in this case, private var temp. If anybody's familiar with Linux, what's the problem with private var temp? It's writable by every single user on the system. However, there is a caveat. It's got a sticky bit, but I'm not going to go into that. So any privileged operations that happen in this directory, a low privileged user could leverage to essentially attack root. So as you can see here, the installer makes use of private var temp VMware deemed service universal.package within that directory. So I, as an attacker, know it gets written there, know it gets executed as an administrative user. I could leverage that for elevation of privilege. So I'm going to give a step-by-step overview of actually how trivial this exploit was to exploit. I'm saying exploit 20 times a second. So first things first, if you, as an attacker, I create a fake directory prior to installing this software, prior to clicking the button, one click, quote unquote. Then I create a symlink targeting the legitimate directory, pointing it to another directory where I own, I have control over it. I then essentially have a loop which constantly checks if this package has been written to the symlink directory, aka pointing to my now controlled directory. And then if it exists, I remove the symlink, recreate the directory, and then I can place my malicious package in the directory that it thinks the legitimate package exists in, therefore achieving elevation of privilege. So as you can see here, I've literally clicked install VMware Horizon, got a calculator pop so I can visually see that I've elevated or got execution and achieved code execution as root. So that was essentially elevation of privilege in one click, quote unquote. Cool, yeah, root. So that also brings us on to a second piece of software that was in the environment. As part of the same assessment, I reviewed management and administration scripts. So these were like helpers that were available, custom helpers that would kick off an action, things like fixing SSO or etc., or like pieces of software that are broken. This specific script was responsible for reinstalling Zscaler Client Connector. If you're familiar with like VPN software, it's basically the same thing. It's a zero trust network access piece of software that allows you to access resources, etc. So essentially, what this script does was it downloaded a file specified by the fifth argument, or 4 because it starts from 0. It unzips the package into temp, same issue as before. It then attempts to find a specific string within the directory listing, which is looking for Zscaler-OSX, which is the architecture binary for that platform. And then it executes a hard-coded path within that directory that it's identified and sets up Zscaler, signs into the public service edge, etc. So, who in the room sees the problem with this? Yeah, cool. Or even better, who sees multiple problems with this? Yeah. So it makes use of an insecure directory. It makes use of temp, which is not good because every single user on the system has read, write, execute within that directory. There is a caveat with temp. As I mentioned earlier, it has a sticky bit. So if I, as an administrator, wrote something to that directory and then another user tried to modify the file that already existed, I wouldn't be able to, despite having control of files in that directory. However, I don't need to exploit the use of just /temp because it extracts the archive that it's written into a known location and then just tries to find a string. So as an attacker, if I were to just create literally /temp/Zscaler-OSX that's a bash script, there'll be 2 cases of it, and the result will be, as it's just running ls, piping the result into grep. It will have 2 items there, and therefore I'll be able to I'll be able to have my malicious item prior to the legitimate one, and therefore the script gets executed, my script gets executed as root. Cool. Again, leading to literally a one-click, not one click if you include the writing the script to the file system, but code execution as root in 1 click. So how does this kind of stuff happen? When I was investigating this, I was just looking for hard-coded strings within the script, and I found a number of cases on the actual like Jamf and Zscaler like community like platforms, and it seemed to be a case where what this team had done is they copy and pasted an example provided by another community member, not actually provided by Jamf or Zscaler, and thus introduced a vulnerability into their environment. So if anybody's a developer or if anybody does any like game cheating, etc., this is a case of copy pasta. They literally have copy pasted it and then deployed it in their environment. So cool. So now it's time to talk about a project with client C. So one of my ex-colleagues, Galan, got me involved in a scoping process for one of our clients. We produced a scope of work where we were reviewing Zscaler Client Connector and essentially the posture policies that were being like applied to a device or enforced on a device prior to connecting to this zero trust network. Essentially, 5 days on Windows, 5 days on macOS. Within like 2 or 3 days, I'd bypassed every single posture policy enforced by Zscaler on Windows and macOS. So I was like to the client, hey, are you okay if I spend some time actually poking at Zscaler, the privilege functionality or the file system functionality? They were cool with it because they were getting some extra value. And during the initial process of reviewing the posture policies, a couple of things like rang alarm bells in my head. I was like, why is it using this file system? Why can I load code within this component, etc. And I found some bugs. I dropped a couple of 0 days in this project as well. This vulnerability essentially stemmed from the ability to execute arbitrary code with an assigned Zscaler component. This is one of the privacy models that macOS has. You're not supposed to run code that's unsigned. You're not supposed to be able to process inject. You can't cross-process inject unless you have specific entitlements. So while reviewing this software, how big is that? Okay, that's fine. While reviewing this software, I was looking at the code signing entitlements of this specific component, Zscaler tunnel, and this gives information about like the identifier, code signing signature, status, etc., runtime version, and also entitlements granted to the application. So in this case, this specific component, Zscaler tunnel, which was an NSXPC binary but not relevant, had 2 entitlements which are valuable as an attacker. It allowed you to load a dilib into the process through an environment variable, and also that dilib didn't need to be signed. So I could essentially impersonate Zscaler within that specific process and use it to achieve objectives. And I'll cover the objectives that I essentially achieved. So within this IPC mechanism that this service was using, it had a privileged process and an unprivileged process. The unprivileged process was like the GUI application where you'd click like connect to VPN, quit, sign in, etc. That would talk to a privileged component, And essentially, in that privilege component, it checked if the connecting client was signed as Zscaler. As I just mentioned, I was able to load code into this Zscaler signed process, therefore able to talk to this XPC service. So as I mentioned before, in this, the binary I was able to load into had a specific identifier, which was com Zscaler tunnel. For a client connecting to this XPC service with that identifier would have two classes available, so tunnel XPC protocol and XPC protocol. As I had essentially that identifier and I was signed, essentially I could call any function within those two classes. While reviewing these classes, one immediately stood out as interesting. I'm saying this with 20/20 hindsight because what I do is I go from the top to the bottom and read every single line of code, but I can say it was that easy to identify. Essentially, this method took a string as an argument and returned a Boolean as a result. It seems like when things return Boolean is typically true or false, or 1 or 0, etc., and a string is an argument for installing things. Somewhat interesting. While reverse engineering this component, you can see that it starts to set up architecture-dependent strings. It's like, interesting. Uninstall application, x86, ARM64, kind of interesting. Seems like it's interesting to me as an attacker. It mentions a path in a debug string. Again, this is good sign. Might as well keep pulling this thread. And then it calls a subfunction, install ZCC. Within install ZCC, it's very clear it's going to execute something on the file system. I, as an attacker, having ability to specify a string, that string is actually the base path of the path that the privileged component is going to execute. So in this case, I, as an attacker, can just provide the string /temp, and then as long as I've set up a directory within /temp or another directory, I can get code execution as root. So you see here, it's specifying the argument I've passed, appending that string to the end. So if I /temp /content /macOS install builder, it will then eventually get passed to run command to shell, and therefore it does what it says on the tin. Here, I essentially just wrote a custom client. You don't need to pay attention to the details. I'm not expecting everybody to know Objective-C, but essentially I just test if I can call get version with reply, and then I send the temp as a base path. And as you can see here in my one-shot script, I run go.sh. It automatically creates the folder structure with a malicious script. It then compiles a malicious dilib to load into that component which was signed by Zscaler, and then calls install revert ZCC from the privilege component, and then reads the result. And as you can see, I've got code execution as root from a low privilege user. So this is the type of thing you'd exploit if you didn't have access to the GUI. It's super easy. It's not just closed source third-party applications that we sometimes exploit in environments. I've seen Swift dialog used in multiple Jamf managed environments. So if you've ever seen a pop-up, a lot of the time it's going to be Swift dialog or the Jamf built in. I was able to, again, exploit a zero-day local privilege escalation within this software in the same client environment. So it was three 0 days on that project. In this case, again, insecure usage of the file system, you always see it. Why is it using /var/temp for privileged operations? In this case, it's specifically changing essentially the permissions on that specific file to be read-write, 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 user, group, world. So in the case that I have control over /var/temp, I can use the same symbolic link trick, point it to something that I want to gain write control over, and therefore I can achieve local privilege escalation or just break the system if I wanted to. So in this case, I just redirected the file system to modify etc sudoers, and then I could just add myself to sudoers config and then elevate whenever I wanted to. Not the most stealthy way of exploiting it, but perfect for a demonstration. Again, same situation happens with a custom installer that was written in-house. In this case, what they did is they developed this script which could install Cisco AnyConnect and automatically set up a provisioning config. Because they were using Zscaler and Cisco, the two weren't compatible. So some people had Cisco, some people had Zscaler, and by default, Zscaler was installed. But anyway, as you can see here, it's using private temp for a package. Not great. So if I can anticipate this being installed, or I have the ability to click reinstall, therefore I can exploit this. Another situation, how does this happen? Googling specific strings, in this case, temp AnyConnect profile XML, and looking for Composer, because I know Composer is used for creating packages. I see another case where it's copy-pasta. They've taken basically word for word from a blog that's a community post, not an official guide, And then there is an official guide by some random company that I've never seen before. And yeah, it introduces vulnerabilities into client environments, which is not great. Cool. So that leads us onto a section where I essentially want to encourage you to get third-party review. Again, it's a bit of a misnomer, a bit of a weird way of saying it, but us as third parties should be used and leveraged in order to secure your environment where you're making use of third-party software. Third-party plus third-party. So third-party software vendors, again, while they say they keep things secure and they constantly have reviews, it's not always the same, they don't always have the same priorities. Us as security consultants, we want to, A, protect our clients, B, get research output, and C, protect the greater good, the greater environment of like third-party software. Again, having a mutual relationship where it's essentially mutually beneficial. We can't always get access to software. We don't always have time to set up entire environments and like replicate client environments. So in the case where we can collaborate with you, we can get access to software we might not necessarily be able to due to like license quantity requirements, etc. And we have a lot of client environments where we observe the same mistakes being made or pieces of software we know are vulnerable, or at least we don't have the opportunity to directly exploit them because they might not be in scope. So essentially, let's collaborate and let's see how we can help you, or like how we can get something where it essentially improves the greater good of the third-party software world. So it's all good and handy, me basically telling you all these software have vulnerabilities, but what actually can you do to make your environment more secure? Essentially, as I just mentioned, be proactive, talk to us. Like, I'm happy to help, happy to have a chat if you want to have a chat about specific software you're concerned about. Essentially, these vulnerabilities weren't specific to Jamf. If you make use of Kanji, it's very likely that this kind of stuff happens if third-party software is vulnerable. Same things happen on Windows. If you make use of like Software Center and SCCM, if the installer, the MSI is being used, is vulnerable, I can still exploit it by clicking install. Same with Company Portal, the Intune Company Portal. If the installer that's being used is vulnerable, it doesn't matter what MDM platform you're using, it's not really much you can do. If you do want to kind of go on this hunting activity where you can try and identify these vulnerabilities without us, you can make use of SIM logs, like SIEM logs. Essentially do hunts similar to what threat hunters do. Look for cases where installers are executed and then after insecure directories are used, so like temp, users' home directories, roaming profiles, etc. And if you develop things in-house, just have somebody look at them, like security teams look at them, have a chat with people that are very familiar with like macOS, or even just people that are familiar with like logical exploitation, logic bugs. And if in doubt, get in contact with me and I'll get something, yeah. So at the end of this talk, go away, go press some buttons, see what the install and uninstall functionality of third-party apps actually do on your endpoints. And yeah, thank you very much for listening. Cool. Are there any questions? Oh, there's one over there.
That was sweet. The temp thing seems to be, in macOS world, seems to be a common like thread all the way through. I think Patrick Wardle did a similar DEF CON talk on a Zoom installer as like a race condition for this very similar thing. What does good look like? What should people be doing? Like as vendors, what should that process look like in a trusted way? Because it seems to be obviously like, I assume that there are smart people there that are making, whether that's a conscious or unconscious decision to use it that way. Yeah. Like is there an Apple thing that's missing, or is it just bad practice and there's better ways of doing that kind of stuff?
So if I were working at Apple, I would start approaching a situation similar to on Windows, where they have like the file system redirection, like anti-file system redirection for like RPC control, where you literally cannot do it even if you wanted to. If a privileged process is interacting with something that is using a symlink across that, it just doesn't work. So that kind of thing, like forbid installer from writing to directories which are overly permissive. That's what I would do if I was developing it. But then again, security isn't always the priority. It's about selling software and yeah, etc. But I personally have my own tooling where every single case where I essentially have like 15 CVEs, which are this kind of vulnerability. They're super easy to find. They're everywhere. Best way to get started. I have my own tooling where some kind of like my own semgrep, where I run a script across the system. If it finds a package, it unpacks it, checks post-install, checks pre-install for these specific strings, etc. But yeah, it's that kind of stuff. Develop tooling to try and proactively identify these things.
And the Zscaler thing you had there, where it could load the dialer without any validation. What did you make of that? Do you think it almost seems like a debugging thing, like you can swizzle functions or something, right? Is that what that terminology is like?
I think it's that, yeah. So I think what I did is I was in a client environment. I had the ability to download every single Zscaler installer for the last X number of years. So I downloaded every single one and then checked up to what point that was introduced. And through the process, it was like an accidental include of something that should not have been in production. So yeah, that kind of stuff.
That's awesome. Thank you.
Thank you.